Hi, everybody. Welcome to section 2.4, the chain rule. So, in this section, these aren't the correct learning objectives. It's a typo, but from today's lesson from 2.4, we were going to use the chain rule to differentiate functions. Okay, so we're learning a new differentiation tool, which is the chain rule. Okay, it makes life a lot easier. So, what is a chain rule? So, let's kind of get into a little bit of a discussion. So what is the derivative of x squared plus x to the third power, right? So from our past, it's not really a product rule. It's not really a quotient rule. One thing we can think about is maybe expanding this and then taking a derivative, right? So it would need to, I don't know, something like x squared plus x times x squared plus x times x squared plus x, multiply all that out and then take a derivative, right? But that's really a big hassle and not fun to do, right? So what we're going to learn is kind of a new trick, which is the chain rule to be able to take a derivative of this. But let's kind of get into the breakdown what taking a derivative using a chain rule is. So from our algebra background, right? What we do know is that x squared plus x to the third power is a composition of two functions, right? Remember composite functions. So using this deduction right here, we can see that g of x is this inside function, right? Which is x squared plus x. And f of x is the outside function, which is this to the third power, right? Let's kind of break down exactly what that means, right? So, same thing. We have f of x equals x cubed, g of x equals x squared plus x, and we have a composite function, right? Fog of x. Well, this actually means just f of g of x, right? And we do know g of x is x squared plus x, so it's f of x squared plus x, but we do know f is x cubed. So what that means is that sorry, I forgot a couple equal signs, but what this really means is that it's just x squared plus x cubed. Okay, so what we're really doing is taking a derivative of a composite function, right? So before we had derivatives of maybe just regular polynomials, maybe derivatives of two functions multiplying each other with the product rule, two functions being you know, f times g, product rule, f divided by, sorry, quotient rule, f divided by g. Now we have a derivative tool for composite functions, f of g of x. And it makes life a lot easier as opposed to trying to multiply this out and taking derivative of that. Okay, so chain rule, that's our new tool. So the definition is a little bit confusing. So if it scares you a little bit, like just be okay. But really it says like if f and g are both differentiable, uh, and f equals f of g, then the composite function, then this is really the formula, right? So if the too many f's confuse you, what you can change this with is, maybe you can have h prime of x, right? Just a different letter, different variable. But what this really means is that it's the derivative of the outside. The inside stays the same times the derivative of the inside. So what does that mean, right? So once again, it's not the easiest to understand based off the definition. So it's always easier to see an example. So let's go ahead and check this out. So, right, we have, once again, I'm going to change this to just h of x, right, just to make the f a little easier to see. I want to take a derivative of this, right? So the formula for chain rule from above is, you know, h prime of x equals the derivative of the outside, the inside stays the same, times the derivative of the inside function. Let me rewrite that, sorry. So what does that mean for this, right? Remember that this is our inside, this x squared plus x, and this 3 is really our outside. So the derivative of this would be this 3 drops down, right? That's our outside function, thinking about it as like a power rule. And we subtract 1 from it, right? So this would be 3 times, and the inside stays the same. So this x squared plus x stays the same. And so we still have this to the second power, right? That's the derivative of that outside. But we still need to find the derivative of the inside and multiply it. So that would be times x squared plus the derivative of x squared plus x, which is 2x plus 1. Okay. And that would be the derivative of that using the chain rule. So, okay, so it takes a little bit of time to get used to it, but really here's a step-by-step of how we use a chain rule, right? We determine what's our inside function and our outside, right? So for the sake of this, you could say, f of x equals x cubed is outside, and g of x equals x squared plus x is inside, right? So we determine our inside and outside functions. We find the derivative of the outside. We find the derivative of the inside, and we use the formula from above, right? Derivative of the outside, inside stays the same, and then times the derivative of the inside. Okay, so that's for the setup. All right, so let's go ahead and stop it right here, and we will see you next time. Thank you. Bye.